Welcome, class, to a Coach Joe workshop.
In this lesson, we will review one of the common design patterns, the builder pattern. We will start with issues working with medium to large size data structures and how the builder pattern solves these issues. In many cases, you will end up writing more lines of code, but the code will be clear and easier to read. Let's open a Java project. I'm going to start with a new project in IntelliJ. Feel free to use Eclipse, STS, or another IDE of your choice. We're going to be building an adventure game and need a data structure to hold monster information. Please remember, this is a lesson on the builder pattern. All of these monster classes should have either an interface or an abstract class if we were building a real adventure game. Let's start with a class called Monster Minimum. This class has one private property with a getter. There is a single constructor that is used to set this required property. Everyone should be familiar with a class that holds a data structure. In this test, you see how we would create a monster minimum object by passing in the monster name into the constructor. This is easy. What happens if we need more properties? What if some are required and others are not required? In this class, monster optional, we have one required property and three optional properties. How many constructors do we need? Tough question. We need to consult the requirements to be sure. Just for fun, let's say we need two constructors. One just for the required fields and another for all the fields. Down below we have all the getters. Here's a test that shows how to build an object with one required property. Here's a test that shows how to build an object with all the properties and the monster is alive. There is another test to prove the monster is not alive if the hit points are set to 0. You should notice that with more properties there could be more possible constructors needed. Also, the developers need to pay attention to the parameter order or values could be misplaced. Let's look at this new class called Monster Many. There are 19 properties. How many constructors do we need? With some required properties and others being optional, it's beginning to get ugly. As many of you may be aware, 19 properties may seem small compared to other classes out there that have 40, 75, and even more than 100 properties. In this class, I kept it simple. There are the same two constructors from the previous class, and one new constructor that takes all the properties. Down below are all the getters. Here is the Monster Many test class. These are the same tests that prove the first two constructors work. In this test, you would see how we would create a Monster Many object passing in all the values in the constructor. Time for a Coach Joe challenge question. Does anyone see a problem building the Monster Many object? The IDE will show the parameter names and that is helpful. Check this out. Assuming you did not see me delete the speed parameter, how could you tell which parameter value is missing? It could be difficult and time consuming. Let me undo that action. Relying on the IDE to show the parameter names is not always available. Correct. Passing a null or a boolean is an indicator of poor code. Coach Joe rule number 37 states that boolean or null parameters should not be passed to methods. Yes, I agree. There are too many parameters for my liking. Coach Joe rule number 14 states that methods should have few, if any, parameters. 0 is the preferred number of parameters, 19 is way too many. I have one more rule to consider. Coach Joe rule number 20 states that objects must be easy to create. With many parameters and possibly many constructors, this object is getting a little complicated to create. Fortunately, there is the builder pattern. The idea is to separate the construction of the object from its representation. There are two approaches I want to demonstrate. The first is the nested class. Here is a dragon class. To keep things simple, I only have 4 properties. You should easily be able to add more properties with the following approach. Here is a private empty constructor that prevents anyone from directly building an object. And here are the 4 getters. With no public constructor, we want to take advantage of the public static class called builder. Please note that I included 2 different builder examples with different names. It is common to only have one builder and use the class name builder. The first builder assumes all properties are optional and it's the responsibility of the developer to know which properties are required. In builder all optional, we create the private properties for this nested class. We create a method that will set each property with an easy-to-read name. Some developers use with, others use set. The method name should be consistent. You will pass in one value and assign it to that property. For the method with hit points remaining, 2 properties were assigned. Each of these methods will return the current state of the builder or the builder all optional object. In the final step, the build method is called that will create the actual dragon class. Here we create a new dragon class. The dragon constructor is private to all outside classes, but it is available to all inside methods and nested classes. Once we have a dragon object, we can assign all the properties collected in the builder class and store them in the dragon object. Here we return the newly created dragon object. Let's look at a few tests. Here's a private constructor test. If I uncomment this line, you will see that there is a compiler error indicating that this is a private accessor. Let's comment this back out. Here's a test that builds the dragon object with the new builder. Take a little time to review this code. We will build a new builder from the dragon class. We chain together all the methods we need to create a complete dragon. Method chaining is used to invoke multiple method calls in a single statement. Each method returns an object that allows the call to be chained together without the need of storing intermediate results. After we chain all the methods, we finish with a call to the build method. The result is a dragon object. We can run this test. And it passes. In some cases, you may not need to populate all properties. Here is a test that excludes the gold pieces. If we run this test, the dragon is created and the value found in gold pieces is 0. Back in the dragon class, there is another builder you could use that forces required parameters to start the process. Here, the builder required constructor static class has its own constructor that requires one parameter, the monster name. The remainder of the code is the same as above. Here is a test that shows how to build a dragon with the builder required constructor. Again, this code should look very similar. If we run this test, it should pass. When given a choice, use the first static builder, builder all optional, over the builder required constructor. The builder required constructor could end up with many parameters, which is an issue we were trying to solve. The second approach I wanted to show is the external class. Here is a skeleton class. As before, here are our 4 properties. Notice we have an empty public constructor, not private. We also have a public constructor that accepts all the properties. Down below are all the getters. Here is a skeleton builder class. Again, here are the 4 properties. Here is an empty public constructor. The first method is how you start the builder, by building a skeleton builder. Get it? These methods have the same naming convention as the nested class approach and will assign one value to a specific property. The final method should look familiar. It is the build method that returns the desired object. Notice that it calls the skeleton constructor and passes all the values as parameters. This is something we were trying to avoid with the builder pattern approach. Here's a test that proves the skeleton constructor works. And here's a test that proves the skeleton builder class will build a skeleton object. And if we run this test, it will pass. You should prefer the nested class approach over the external class unless you have a specific need. Now, in case you wanted to force the skeleton builder to use required properties, you will need to add this constructor. If you were to require the monster name to be in the constructor, you should remove the method call with monster name. Here's a test that shows how to build a skeleton with the required property in the builder constructor. Let's run this test. And it passes. Here's a test that will serialize a dragon object to a JSON string using Jackson. And here a different dragon object is created from the JSON string. Let's run this test. And it passes. Here is the same test for the skeleton object. Let's run the test. It also passes. Jackson will find the empty private constructor in the Dragon class by using reflections. You need to have an empty public constructor in the Skeleton class or Jackson will throw an error. Let's comment out the public constructor inside the Skeleton class. Now let's run the JSON test inside the Skeleton Builder test. Notice we get an invalid definition exception error. Make sure you have a public constructor if you use the external builder approach. Let's discuss some pros and cons with the builder pattern. Reducing the number of parameters passed should be a rule you should follow at all times. Poor decisions can affect others down the road. Best to always follow the established rules. Null and booleans should never be passed as parameters. Building objects becomes easier to read in code. Confusion is also reduced with the use of the explicitly called builder methods. There is design flexibility by allowing the developers to pick and choose the properties to be included with the new object. The builder pattern does require more lines of code. By using the builder pattern, you can now instantiate the object with a single command. Because there are no setters, this promotes immutability as well. You should now have an understanding of the builder design pattern. Examples were shown where the object was created without the builder pattern, along with examples using the nested class and external class. When possible, use the nested class approach. The concept of method chaining was described and shown in the examples. Finally, we discussed several pros and cons of the builder pattern. Your optional homework assignment is to create another class with the nested builder class. Build a unit test to prove the object is successfully created. Remember, future senior developers, make it work, prove it works, then make it better. Ready?
Break!